The ocean covers more than 70% of Earth's surface, a world larger than all continents combined. From afar, it appears calm, smooth, even monotonous. But that is just the surface, and the surface never tells the whole truth. Billions live near the sea, interacting daily, swimming, fishing, surfing. To them, the ocean is familiar, close, sometimes even endearing. That familiarity can sometimes be the greatest danger. Even with ships weighing hundreds of thousands of tons, the ocean remains immense. In the open sea, even the largest ship is just a speck on the water. When the ocean awakens, no human machine is sufficient. Most of the ocean's power is hidden below the surface. Massive currents and layers of water with different temperatures and pressures are constantly moving. The ocean is a vast energy machine operating continuously, 24 hours a day. Then the sky changes. Dark clouds roll in from the horizon. Winds begin to howl. The previously calm ocean starts to move, and the first waves rise. This is when the ocean begins to show its true face. Ocean wall. The ocean wall, not a scientific term, but how humans describe moments when the ocean rises like a massive wall before them. A wall with no doors, no escape, made not of stone or concrete but of millions of tons of moving water. Today, we will explore all the forms this wall can take. Everything usually begins like this, a normal afternoon at sea, nothing unusual. The ship runs smoothly, radar shows no alerts, the crew has no reason to worry. Then everything changes in less than a minute. Suddenly, a massive wall of water rises ahead, taller than the ship's cabin, standing upright like a true wall. Not an illusion, not an exaggeration, hundreds of thousands of tons of water rushing straight at you. And you have only a few seconds to decide what to do. The most terrifying aspect is not the wave's height, but its mass and speed. A 20-meter wave carries energy equivalent to dozens of large bombs, all focused on a single point. Even the thickest steel ships can be broken under that impact. Physically, ocean waves are not water moving forward, they are energy transmitted through water. When this energy encounters shallower water or interacts with other waves, it is compressed and bursts upwards. This is when a normal wave can become a vertical wall of water. And then, as quickly as it appeared, the water wall vanishes. The sea returns to normal as if nothing happened. Only the traces on the ship tell the story. The ocean never apologizes, and it never warns in time. Among all ocean phenomena, nothing is more mysterious and terrifying than rogue waves. They appear suddenly in calm seas, towering 2 to 3 times higher than surrounding waves. No warning, no signs, no time to prepare. For decades, sailors told stories of giant ghost waves, appearing from nowhere and vanishing without a trace. Science once dismissed them as legend until modern instruments confirmed their existence. Today, we know rogue waves occur more often than anyone thought. The formation of rogue waves involves the convergence of energy from multiple directions. When waves from different storms meet at the right time and angle, they resonate and erupt. Like small sounds combining into a massive explosion, the ocean can create a giant wave from ordinary waves. The pressure exerted by a rogue wave can reach up to 100 tons per square meter. Even thick armored glass on modern ships can shatter in an instant. Many unexplained maritime losses are now attributed to rogue waves. Today, scientists use satellites and floating buoys to monitor rogue waves across the oceans. Data shows dozens of rogue waves appear and disappear daily worldwide. Yet predicting their exact time and location remains a major challenge for modern science. Even the world's largest modern cruise ships have fallen victim to rogue waves. Passengers dining or sleeping in cabins are suddenly thrown as the massive wave strikes. The ocean does not care about your size, technology, or schedule. Viewed from space, a tropical cyclone looks like a perfect machine, circular, symmetrical, and strangely beautiful. But within that beauty, hundreds of billions of joules of energy are released every second. A large storm can generate energy equivalent to thousands of nuclear bombs per day. Inside a major ocean storm, wind and waves are no longer separate entities. Wind tears across the sea, lifting water into dense, salty mist that obscures vision. The boundary between air and water disappears. The entire surrounding space becomes a chaotic, wet mass. The true power of a storm lies in how its elements combine like a perfect destruction machine. Low pressure at the center pulls the sea upward. Wind pushes water to shore. Waves keep stacking. No single factor is strong enough alone, but together, they create something no structure can fully resist. For fishermen caught off guard by a storm, each wave is a life or death challenge. The boat faces not one wave, but a continuous series of waves. Just as one is overcome, another arrives. The storm never gives time to recover. On land, storm surge can turn coastal neighborhoods into part of the ocean in a few hours. Not just waves, the entire sea level rises meters above normal. Streets, houses, ordinary life, all submerged under the massive water wall of the storm. After the storm, the ocean returns to calm as if nothing happened. But what remains on land and underwater is evidence of undeniable power. Nature does not explain or apologize. It simply exists by its own rules. Along vertical coastal cliffs, the ocean and land engage in a millennia-long dialogue. Each wave crashing against the cliffs is a question, and the answer is always the booming explosion of water breaking. This dialogue has gone on for millions of years and will continue long after humans are gone. When a massive body of water crashes into the cliff, it has nowhere to go but up. Water pressure compresses within cracks in the rock, then erupts into massive white columns. The impact reverberates for kilometers, a primal sound no human language can fully describe. From above, the moment waves engulf the cliff tip looks like the ocean swallowing the land. For a few seconds, it's impossible to distinguish rock from water, all submerged in a chaotic white. Then the water recedes, and the cliff reappears, eroded slightly, but still standing. Every year, millions of tourists visit these sites to witness the ocean's power from a safe distance. But safe is relative. Sudden waves have repeatedly swept away those standing too close. The ocean is not a performance for spectators. It is a natural force indifferent to our presence. Few places on Earth are as beautiful as tropical coral seas, jade waters, white sands, golden sunlight. But this paradise hides one of the ocean's most dangerous traps. Just beneath the clear water, coral reefs can turn gentle waves into deadly forces. When waves travel from deep to shallower waters, their energy is suddenly compressed. Coral reefs act like an invisible dam, forcing all wave energy upward. The result is waves standing upright, crashing with immense force over shallow water. Waves breaking on coral reefs create perfect barrels, a paradise for professional surfers. But just below, a few decimeters down, the coral is as hard as concrete. A misjudged fall can turn a beautiful ride into a disaster. For small boats, tropical coral reefs are among the most unpredictable dangers in the ocean. The water may look shallow and calm, yet waves can suddenly rise and crash with no warning. Many ships have sunk in areas that appear deceptively safe. In polar glacial bays, the ocean and ice coexist in a cold and serene beauty. Ice cliffs hundreds of meters high rise straight from the water, white and blue like gemstones. It appears as one of the most peaceful places on Earth, until the ice begins to move. There is no warning except for loud cracking sounds echoing like gunfire from the ice cliff. Thousands of tons of ice break off and fall freely into the water below. The impact creates a minor seismic shock, and a wave radiates from the collision point at terrifying speed. Within seconds, the calm water of the entire bay turns into chaotic waves. Boats moored kilometers away from the breaking ice are violently shaken. This is a perfect example of how the ocean transmits energy across distances. No wind, no storm required. After breaking off from glaciers, icebergs become moving walls in the ocean. Only about 10% of their mass is visible above water. 90% remains hidden below. Icebergs drift along currents, silently and invisibly in darkness or thick fog. On a larger scale, polar ice melt creates an invisible wall that is becoming increasingly real. Sea levels rise every year, centimeter by centimeter, quietly encroaching on land. This is the slowest but most formidable version of the ocean wall, unseen yet unstoppable. Deep beneath the ocean surface, there exist boundaries visible but untouchable. Where two water masses of different temperatures meet, they form a clear boundary like a glass wall. This is the thermocline, a temperature boundary, one of the ocean's most powerful invisible walls. The ocean is not a homogeneous mass of water. It is divided into distinct layers like giant compartments. Each layer has its own temperature, salinity, and density, creating real physical boundaries. These invisible walls determine ocean currents, marine life distribution, and entire ecosystems. Beneath the ocean, massive waves exist that are invisible from the surface. Internal waves travel along boundaries between water layers, reaching heights of hundreds of meters. They affect submarines, underwater pipelines, and the entire oceanic transport system. For marine life, these invisible walls are true boundaries for survival. Many fish, squid, and plankton cannot cross temperature or salinity limits. These unseen walls shape the entire distribution of life in the ocean. Experienced seafarers share one thing in common. They never say they conquer the ocean. They say navigate through, and they know that every successful journey relies on careful preparation and a measure of luck. Respecting the ocean is not weakness. It is wisdom accumulated over generations. Modern technology allows us to measure, monitor, and forecast the ocean better than ever. Satellites, autonomous buoys, and unmanned submarines continuously collect data from every corner of the ocean. But forecasting is not controlling. Our knowledge increases, yet we are no closer to controlling the ocean. Lifelong fishermen possess knowledge that no textbook can teach. They read the color of clouds, wind direction, water color, and even the scent of the sea to know what is coming. This is a lesson passed through generations, learning to listen to the ocean rather than trying to control it. Coastal communities have learned the most valuable lesson: living in harmony with the ocean, not against it. They build higher homes, plant mangrove forests as natural shields, and know when to retreat. Humility before nature is not failure. It is the wisest survival strategy. The ocean has existed for billions of years before humans appeared and will continue long after us. Giant walls of water, rogue waves, collapsing glaciers, and invisible boundaries beneath the sea all serve as reminders that we are merely small guests on this planet. The greatest lesson the ocean wall teaches is not fear, but humility, respect, and understanding that there are forces far beyond human limits. Over 70% of Earth is covered by oceans. Yet global trade and energy flows depend on a few incredibly small points. These are strategic straits, where history, geography, and power converge. Every day, thousands of ships carrying oil, gas, food, and goods pass through these narrow corridors. Even a small disruption can shock the global economy. These are known as strategic choke points. Among hundreds of straits worldwide, 5 stand out: Hormuz, Malacca, Gibraltar, Bosphorus, and Bering. Each has unique natural conditions that shape its value and risks. Our journey will take you through each strait, exploring their natural conditions, trade importance, and geopolitical roles. Let's begin with the most volatile strait on Earth. From space, the Strait of Hormuz appears as a narrow passage connecting the Persian Gulf to the Arabian Sea. At just 34 kilometers wide at its narrowest point, it is the world's most critical energy artery. Every year, billions of dollars worth of oil flow through it. What many don't realize is that the seabed of Hormuz is relatively shallow, averaging less than 60 meters. This makes it highly vulnerable to blockades using mines or submarines. Militarily, its shallow depth is a key control factor. The surrounding terrain of Hormuz is dominated by deserts and rugged mountains, especially on the Iranian side. These provide ideal positions for missile systems and surveillance. Nature itself has granted Iran a significant strategic advantage. Every day, around 21 million barrels of oil pass through Hormuz, nearly 1/3 of global supply. Warm waters and relatively calm seas favor navigation, but the extremely dense traffic means any incident can have serious consequences. No other strait on Earth concentrates as much oil flow as Hormuz. It supplies energy to much of Asia, Europe, and the United States. If Hormuz were closed for just 1 week, global oil prices would surge immediately. This region is a constant flashpoint between Iran and the United States. Tehran has repeatedly threatened to close the strait in response to sanctions. Washington maintains a naval presence here to ensure freedom of navigation. All Gulf nations, including Saudi Arabia, the UAE, Iraq, and Kuwait, rely heavily on Hormuz to export oil. There are no strong alternatives, which is why the strait is protected at the highest international level. History has shown that whenever tensions rise in Hormuz, global oil prices surge instantly. In 2019, tanker attacks sent shockwaves through global markets within hours. Iran has heavily invested in small submarines, fast attack boats, and coastal missile systems, all designed to dominate Hormuz's narrow and shallow waters. This asymmetric power forces even major powers to think twice. Hormuz stands as the clearest symbol of the world's dependence on tiny geographic, just 34 kilometers wide, yet capable of shaping the fate of the global economy. This is where nature and geopolitics converge at their peak. If Hormuz is the artery of oil, then Malacca is the bridge between two great oceans. Stretching over 800 kilometers, it connects the Indian Ocean to the Pacific, running between the Malay Peninsula and Indonesia's Sumatra Island. Malacca is the second busiest shipping lane in the world, after the English Channel. Over 80,000 ships pass through each year, carrying around 30% of global trade. A humid tropical atmosphere blankets this busy route year-round. Unlike Hormuz, Malacca is shallow and winding in many sections. The shallowest point is around 25 meters, limiting ship size. Ultra-large tankers are forced to reroute through Lombok or Sunda, adding days to their journey. Tropical weather creates major navigation challenges. Dense fog, heavy rains, and complex currents between islands often reduce visibility. Local pilots are essential for guiding large vessels safely. China, Japan, and South Korea rely heavily on Malacca for energy imports from the Middle East. This is why Beijing calls it the Malacca Dilemma, one of its greatest strategic concerns. Malacca has a long history of piracy. Small, fast boats can hide among countless islands before launching sudden attacks. Joint patrols by Malaysia, Indonesia, and Singapore have significantly reduced these incidents in recent years. Singapore, small yet incredibly wealthy, has built its prosperity on its position at the gateway of Malacca. This port is one of the busiest and most efficient in the world, handling billions of dollars in goods annually. At its narrowest point near Singapore, the two shores are less than 3 kilometers apart. Small fishing boats and massive container ships share the same narrow waters. The traffic management system here is as precise as air traffic control. China has invested billions in alternative routes, including pipelines through Myanmar and ports in Pakistan and Sri Lanka, all to reduce reliance on Malacca. This shows how a single strait can shape the strategy of a global power. Malacca is more than just a strait, it is Asia's lifeline. Trade, energy, and power for much of the continent flow through these waters. It is no surprise that every major power seeks influence here. Mount Gibraltar, a limestone massif overlooking the sea, was once called by the ancient Greeks one of the two pillars of Hercules, the boundary between the known world and the boundless ocean. Today, it remains just as strategically important. Gibraltar is where two very different seas meet. The Atlantic Ocean and the Mediterranean create powerful, complex currents, with surface and deep waters flowing in opposite directions. Weather in Gibraltar is highly unpredictable. Westerly poniente winds and easterly levant winds can collide, creating sudden storms. Ships must closely monitor conditions before crossing. Gibraltar is a British overseas territory, despite sitting on Spain's doorstep. A centuries-long sovereignty dispute between the UK and Spain remains unresolved, further complicated by Brexit. For NATO, Gibraltar is a vital gateway. Controlling the strait means controlling the flow between the Atlantic and the Mediterranean, from the Americas to the Middle East. Tens of thousands of ships pass through Gibraltar every year, linking Europe to the Mediterranean and beyond. It is a vital trade route, especially for economies dependent on energy imports. Gibraltar is more than a strait. It is a symbol of maritime power through the ages. Whoever controls it controls the gateway between East and West, a position that remains unchanged today. No strait in the world is as iconic as the Bosphorus. Just 31 kilometers long and less than 700 meters wide at its narrowest point, it divides Istanbul in two and separates Europe from Asia. The Bosphorus features a unique two-layer current system. Less saline water from the Black Sea flows on the surface toward the Marmara, while denser, salter water flows in the opposite direction below. This creates unique underwater conditions. Few straits pass directly through a make-acity like the Bosphorus. Massive oil tankers travel just hundreds of meters from dense residential areas. A single accident here could trigger an immediate disaster for millions. The Bosphorus, together with the Dardanelles, forms the only outlet from the Black Sea. Countries like Russia, Ukraine, and Romania depend on this route to access global waters. It is a powerful geopolitical leverage point. The Montreux Convention of 1936 grants Turkey control over the Bosphorus. Ankara can restrict or close the strait to foreign warships during times of conflict. It is one of the most unique strategic powers in the world. During the Russia-Ukraine war, the Bosphorus became a global diplomatic focal point. The Black Sea grain deal allowed Ukraine to export food through the strait, preventing hunger for tens of millions. The Bosphorus directly impacts global food supply. Beyond its surface, the Bosphorus is also connected beneath. The Marmara Tunnel runs 60 meters below the seabed, linking European and Asian rail networks. It stands as a remarkable feat of modern engineering. The Bosphorus is not just a shipping route, it is the geopolitical heart of Turkey. Ankara leverages control of the strait to balance relations between NATO and Russia, maintaining strategic influence during global crises. Over 40,000 ships pass through the Bosphorus each year, more than the Suez Canal. Oil, gas, grain, and goods all move through this narrow waterway cutting through a immensity. It is one of the busiest and most complex straits in the world. At the far north, where Alaska and Siberia are just 86 kilometers apart, lies the Bering Strait, a natural boundary between the United States and Russia. In winter, temperatures drop to minus 30 degrees Celsius, and ice covers almost the entire surface. It is one of the harshest seas on Earth. For most of history, the Bering Strait has been nearly unusable for commercial shipping. Blizzards, dense fog, and thick ice make navigation extremely dangerous. Only specialized fleets, particularly from Russia, operate here regularly. Climate change is transforming everything. Arctic ice is melting at an unprecedented rate, with summer ice coverage down more than 40% compared to the 1980s. New shipping routes are beginning to emerge. The Arctic route through the Bering Strait can shorten travel between Europe and Asia by up to 40%. A journey from Rotterdam to Tokyo could take around 15 days instead of 25. This translates into billions of dollars in savings each year. The Bering Strait is becoming a new arena of competition between the United States, Russia, and increasingly China. Whoever controls this region may control future trade routes and vast Arctic resources. The Bering Strait reminds us that nature is changing, and with it, the global balance of power. A once-forgotten passage is emerging as a future shipping route, bringing both opportunity and new conflicts. Looking back, each strait has completely distinct natural characteristics. Hormuz is shallow and narrow. Malacca is tropical and complex. Gibraltar has powerful currents. The Bosphorus features two opposing water layers. Bering is frozen and harsh. These differences define their unique value and risks. These straits do not exist in isolation. They are nodes in a global trade network. A disruption at any point can trigger a chain reaction, from financial markets to the daily lives of billions. Control over strategic straits directly influences global negotiations. They are bargaining chips in economic, military, and geopolitical alliances. Whoever controls these gateways holds greater influence over the world order. From space, Earth appears as a water planet. Yet these narrow passages shape the destiny of 8 billion people. Straits are not just pathways for ships. They are where history is written and the future is shaped. At sunrise, the Persian Gulf looks as if nothing has ever happened here. The surface is calm, silent, endless. But beneath that still water, beneath hundreds of meters of sediment and ancient rock, lies something that has shaped modern human history for more than a century. The Arabian Sea spans more than 3.8 million square kilometers. Most of its seabed has never been touched, fully mapped, or drilled by humans. It remains one of the least understood regions on Earth, and potentially one of the richest yet to be explored. In these shallow waters, oil has been discovered and extracted for more than 80 years. The Middle East's first oil wells lie just beneath, shallow, accessible, easy to reach. But the easy resources are running out. And human ambition is now moving farther and deeper. This is a boundary humans have seen for thousands of years without understanding its geological meaning. The color shifts because the seabed suddenly drops hundreds of meters. On one side lies the continental shelf, explored and known. On the other lies the deep ocean, where the real secrets remain. At night, the ocean guards its secrets even more carefully. No aircraft can see through it. No satellite can penetrate its depths. What lies beneath is safer than any vault on land. And that is exactly why the most critical explorations happen in silence, often under the cover of darkness. From June to September, the southwest monsoon turns the Arabian Sea into a nightmare. Waves reach up to 5 meters, visibility drops near zero, and underwater currents become unpredictable. Deep-sea exploration is limited to the remaining 8 months, and every calm day comes at a cost. 50 meters deep, sunlight still exists. Colors still exist. Life still exists. But as you go deeper, everything changes. Light fades. Colors disappear. And at a few hundred meters, it becomes a world where humans cannot survive without machines. This is what oceanographers call the twilight zone, where the last traces of light disappear. Below lies only darkness, pressure, and absolute silence. And in a place untouched by sunlight, beneath thousands of meters of cold water, ancient hydrocarbon deposits may still remain, undisturbed since their formation. At 200 meters deep, the world is completely different. Pressure is 20 times that at the surface. Temperatures drop to 7 to 10 degrees Celsius. A fine layer of sediment stretches endlessly like an underwater desert. And beneath it, Earth's geological history is recorded layer by layer. Each meter deeper represents thousands of years. This is the edge of the continental shelf, where land ends and the abyss begins. These cliffs rise hundreds of meters, nearly vertical, recording hundreds of millions of years of geological history in stone. Geologists read them like treasure maps, searching for signs of hydrocarbon traps hidden below. At 1,500 meters, pressure reaches 150 times atmospheric levels, enough to crush human bones instantly. Temperatures approach freezing. No light, almost no currents. Yet within this pale sediment, methane molecules sometimes seep upward, a signal that something lies deeper below. These bubbles are not random. Methane seepage is the clearest geochemical signal of hydrocarbons below, like smoke revealing fire. In the deep Arabian Sea, such seeps have been recorded in multiple locations. Each stream of bubbles is an arrow pointing downward, toward the answer. Hydrothermal vents reveal intense geothermal activity beneath the seafloor. This activity is part of the long process that forms oil over millions of years. Where the Earth is still hot, where the subsurface is still active, the conditions for hydrocarbon formation may still exist. Not only in the past, but even today. Each sediment layer is a page of history. Brown marks shallow, life-rich seas. Gray signals deep, oxygen-poor waters. Black layers contain organic material, the precursor to oil. Geologists read these cores and witness hundreds of millions of years unfold before them. Even in total darkness, life persists. These creatures have evolved over millions of years to survive conditions humans cannot endure. The deep ocean is not lifeless. It is a complex, fragile ecosystem. Cold water corals live at depths of hundreds to thousands of meters, without sunlight. They grow slowly, live for thousands of years, and support entire ecosystems. Yet they remain invisible to the surface world until human activity reaches them. At 4,000 meters, the seafloor is flatter than any land plane. Red sediment accumulates incredibly slowly, less than 1 millimeter per thousand years. This is one of the quietest places on Earth. And beneath it, seismic data suggests massive geological structures that may have never been explored. This seismic vessel is mapping what lies beneath the seabed using sound waves. Air guns fire powerful pulses downward, through water, mud, and rock, before they reflect back. This is how humans see through thousands of meters into the Earth. These streamers stretch up to 12 kilometers, longer than Mount Everest is tall if stood upright. They carry thousands of ultrasensitive sensors, detecting vibrations far beyond human perception. A single day of data can reach millions of gigabytes, more than entire national libraries. Every 20 seconds, air guns fire, releasing pressure waves traveling at 1,500 meters per second. When they hit boundaries between rock layers, part of the signal reflects back. From this, scientists reconstruct a three-dimensional image of the subsurface. Semi-submersible rigs operate in waters up to 3,600 meters deep. From the platform, a drilling column kilometers long is lowered like a needle through water and into the earth. It is one of the most complex engineering systems ever built to find oil. The ROV is the human eye and hand in the deep ocean. Weighing several tons and protected by titanium, it connects to the surface through a thin fiber optic cable. Data and images stream back in real time with almost no delay. A movement that seems simple, but performed at 2,000 meters under crushing pressure. Operators control robotic arms with millimeter precision. This 1-meter core sample could hold answers worth billions of dollars. An FPSO processes, stores, and offloads oil entirely at sea. Can handle hundreds of thousands of barrels per day. In contested waters, its mobility becomes a strategic advantage fixed platforms cannot match. Each kilometer of deep-sea pipeline can cost over $10 million. These lines stretch hundreds of kilometers, linking wells to ships or shore. Repairing them is as complex as rebuilding a skyscraper underwater. Not every vessel at sea belongs to oil companies. Some are research ships operating quietly, collecting data never made public. And it is precisely that hidden data that raises the most questions. The Strait of Hormuz, a narrow stretch of water less than 50 kilometers wide at its narrowest point. Yet every day, around 21 million barrels of oil pass through it. Tankers move in organized lanes like highways at sea, carrying the energy that fuels the global economy. This is not just a shipping route, it is the main artery of the modern world. A VLCC, a very large crude carrier, can transport up to 2 million barrels of oil in a single journey. Stretching over 300 meters and weighing more than 300,000 tons fully loaded, these ships move slowly like drifting mountains. Their immense inertia means they require up to 8 kilometers to come to a full stop. Every day, hundreds of these giants silently carry energy across the planet. It is no coincidence that the world's most powerful navies maintain a presence here. Every oil shipping route is a strategic corridor that must be protected. Every offshore platform is a potential target. In these waters, energy and military power are inseparable. This is conflict without gunfire. A vessel appears not to attack, but to assert presence, to signal ownership over the waters. And whenever geological data begins to reveal valuable resources, these silent confrontations become more frequent. The flames burning atop offshore platforms are flared gas. Natural gas released alongside oil but burned due to lack of transport infrastructure. From space, these flames glow like artificial stars. Each one is a clear signal oil is being extracted below. In deep waters, such flames have yet to appear, but that may soon change. On maps, maritime borders are just straight lines. In reality, they are invisible. Water does not recognize ownership. Fish do not carry passports. But when oil lies beneath disputed zones, those invisible lines become boundaries worth billions, and suddenly they matter immensely. This is a common scene in disputed waters. A survey vessel enters a contested zone and is quickly intercepted. No weapons, no collision. Just a clear message. The data beneath this seabed is not meant to be shared. From the deck of a drilling vessel in the Arabian Sea, there is no land in sight, only endless water and sky. But beneath the ship, a drill string descends thousands of meters into the earth, searching for something that could reshape an entire region, or perhaps nothing at all. Hormuz is one of the busiest maritime routes on Earth. Hundreds of vessels pass through it daily. And if a new deep-sea oil field is confirmed to the south, that number will rise significantly. More opportunity, but also more risk. The Arabian Sea during storm season is one of the harshest environments for engineering on Earth. Waves rise to extreme heights, winds exceed 100 kilometers per hour, and underwater currents shift unpredictably. These forces can destroy any structure not built to perfection. It is one of the reasons why these deep waters remain largely unexplored. On the open ocean, every vessel is supposed to have an identity. But sometimes, there are ships that choose not to be seen. No clear flag, no AIS signal. They move through the darkness, appearing and disappearing from global tracking systems. And most notably, these gaps often occur in the deep Arabian Sea. AIS tracking systems can detect nearly every ship on Earth, but they are not perfect. Those who understand the system know exactly when and where to disappear. A vast stretch of ocean with no signals, no traces, in one of the world's most critical maritime regions. And that is no coincidence. At night, satellites reveal the truth most clearly. The Persian Gulf glows with hundreds of lights from offshore platforms and vessels. But beyond it, the Arabian Sea fades into complete darkness. No lights, no recorded activity. But in the world of energy, silence rarely means absence. It often means concealment. Beneath the surface, another world operates unseen. Military submarines move silently, collecting data, tracking signals, listening to every movement. In the deep-sea energy game, geological intelligence is as valuable as military intelligence. And nations are willing to go to great lengths to obtain it first. Sea fog hides everything, much like the world of deep-sea oil. The ships, the money, the power, it is all there. But no one sees the full picture. Each side sees only a fragment, or only what they are allowed to see. And within that fog, decisions are made that can reshape entire regions. From the Arabian deserts, massive sandstorms can sweep hundreds of kilometers out to sea, erasing visibility entirely. Surface operations come to a halt. But thousands of meters below, there is no storm, no wind. What lies beneath the seabed remains untouched by the chaos above. It has been there for millions of years, waiting. At sunset, offshore rigs appear almost beautiful, like silhouettes against a burning sky. But beneath that beauty lies a different reality. These machines drill deep into the earth, extracting resources that took millions of years to form. And every barrel brought to the surface is a piece of the past that will never return. Above the ocean, surveillance aircraft monitor every movement below. Every vessel, every platform, every anomaly is recorded. The data is analyzed, compared, and stored. In this world, almost nothing remains truly hidden, except for one thing: what lies deep beneath the seabed. From above, the Arabian Sea at dawn appears untouched by human hands. A flawless mirror reflecting a pale pink sky. Yet beneath that calm surface lie billions of tons of hydrocarbons, resting for hundreds of millions of years. The question has never been whether they exist, but who will claim them, and at what cost. The sea knows nothing of oil, nothing of money or power. It simply does what it has always done, moving, eroding, and reshaping the world. And when humanity is gone, the ocean will erase every trace. The only question is, before that happens, how much will we take? Every oil platform has an end. When the reserves run dry, these massive steel structures are dismantled, cut apart, and removed. The cost can reach billions of dollars. But what has been extracted never returns. On the seabed, only traces remain, steel memories of what once stood. Out at sea, there are moments when all boundaries disappear. Water and sky merge into a single horizon. And somewhere beneath that line, the answers remain hidden. Not in maps, not in political agreements, but within the silent layers of sediment far below. At sunset, the Arabian Sea becomes a breathtaking canvas of light, beautiful enough to make one forget what lies beneath. But as the light fades, darkness takes over. And in the depths where sunlight never reaches, the secrets remain untouched, waiting for those bold enough to uncover them. Night falls, and the ocean returns to its true nature: dark, deep, and endless. What lies beneath does not disappear. It only becomes quieter, more patient. The story of oil is not over. It is simply shifting from desert sands to ocean depths, and the seabed has not yet told its full story. On the world map, there is a narrow strip of water less than 33 kilometers wide, so small it is easy to overlook. Yet every day, 30% of the world's oil passes through here. It is called the lifeline of civilization. Every day, around 21 million barrels of oil silently pass through here, carried by massive tankers longer than 3 football fields. They come from the oil fields of Arabia and travel to every corner of the world. There is no alternative route. The Strait of Hormuz lies between Iran and the Arabian Peninsula, a single gateway connecting the Persian Gulf to the Indian Ocean. Its full width is 33 kilometers, but the actual shipping lanes are only about 3 kilometers each way. It is one of the most closely monitored geographic spaces on Earth. Thousands of years ago, Arab traders sailed these waters, carrying spices, pearls, and silk to India. Hormuz was once an independent trading empire where sea routes converged. Its role has changed, but its importance has never diminished. The human body can survive weeks without food and days without water, but only minutes without breathing. The global economy is the same. It can endure many shocks, but it cannot survive if Hormuz is closed. That is why this place is called the throat of the world. "21 million barrels of oil. That is what the Strait of Hormuz must digest every single day. If poured into Olympic swimming pools, it would fill over 30,000 of them. No other oil transit route on Earth comes close to this scale. China is the world's largest oil importer, and much of it must pass through Hormuz. Every factory running, every car moving, every building being heated in China is tied to this narrow stretch of water. It is a geographic dependency Beijing has never been comfortable with. Japan imports over 90% of its oil through Hormuz. With no significant domestic energy and no pipeline alternatives, it relies entirely on tankers and a single strait. South Korea faces a similar reality. For both nations, Hormuz is not a choice, it is geographic destiny. If supply through Hormuz is disrupted for just a few days, global oil prices could surge by tens of % within 24 hours. And when oil rises, everything rises: transport, manufacturing, food, electricity. The global supply chain tightens like a body cut off from its blood flow. We often think of oil as fuel for cars or planes. But it is also the foundation of plastics, fertilizers, pesticides, paints, synthetic fabrics, and thousands of other products. Half the items in the room you are in contain petroleum derivatives. Hormuz doesn't just carry fuel, it carries modern industry itself. India, one of the fastest-growing economies in the world, is also increasing its dependence on Gulf oil. The Jamnagar refinery processes over 1 million barrels a day, most of it arriving through Hormuz. The prosperity of hundreds of millions of Indians is anchored to a strait thousands of nautical miles from Mumbai. The northern shore of the strait belongs to Iran, the country that controls much of this strategic waterway. From here, every passing vessel is within sight, radar range, and if necessary, missile range of Tehran. It is one of the rare geographic advantages Iran holds in the global geopolitical game. Along Iran's coastline, anti-ship missiles like Noor and Khalij-Fars are positioned on rugged mountain terrain. They can strike targets hundreds of kilometers away, and within the narrow confines of Hormuz, no vessel can escape their range. This is asymmetric warfare, low cost, high destructive impact. Iran does not rely only on exposed weapons. Inside coastal mountain ranges, underground bases carved into rockhouse fast boats, missiles, and command centers. Satellite imagery cannot fully reveal them. Conventional bombs cannot easily penetrate them. This is a hidden card Iran holds, and its adversaries know it well. A $13 billion U.S. aircraft carrier can be overwhelmed by hundreds of small speedboats worth only tens of thousands each. This is the swarm tactic Iran has practiced for decades, attacking simultaneously from all directions with speed and overwhelming numbers. In the narrow waters of Hormuz, traditional technological superiority becomes ineffective. Beneath the strait, where no human eye can see, Iran could deploy thousands of naval mines within hours. A single mine can tear open the hull of a supertanker. And once a few ships are damaged or sunk, the entire route can be shut down, not by force but by fear. It is one of the most effective psychological weapons in Hormuz. In response, the United States Navy maintains a constant military presence in the Gulf and the Strait. The Fifth Fleet, based in Bahrain, patrols 24/7, with ships, radar, and satellites tracking every movement. It is a never-ending mutual surveillance, and both sides know a single mistake could trigger disaster. What sounds like a hypothesis has already happened multiple times. In 2019, several oil tankers were attacked near Hormuz, their hulls breached and crews thrown into panic. Oil prices spiked instantly, and global financial markets trembled. Just a few attacks without full-scale war were enough to trigger worldwide economic anxiety. In summer, temperatures in Hormuz can exceed 50 degrees Celsius. The sea becomes a mirror reflecting intense heat, and metal surfaces on ships can burn skin on contact. Crews work in conditions nearly beyond human tolerance, while electronic systems frequently fail under extreme temperatures. From the Arabian Desert, massive sandstorms regularly sweep into the strait, reducing visibility from kilometers to zero within minutes. Navigating a 330-meter-long tanker through a 3-kilometer channel without sight is a challenge captains must face. Radar becomes the only eye, yet even it can be disrupted in the storm. Hundreds of oil tankers operating simultaneously, burning low-grade heavy fuel, create a persistent haze over the strait. Combined with high humidity from the sea and desert sand, the air becomes dense and hazardous. It is one of the most polluted marine regions on the planet. A supertanker requires 3 to 5 kilometers to come to a full stop. In Hormuz's narrow 3-kilometer shipping lane, that means there is no margin for error. Captains must make split-second decisions, relying on years of experience and nerves of steel. A single collision could sink hundreds of millions of dollars and trigger a devastating oil spill in these confined waters. At the gateway of the strait, Hormuz Island appears like a work of art from above. Vivid red soil rich in iron oxide, interwoven with streaks of white, yellow, purple, and orange. It is known as the Rainbow Island. Beneath these extraordinary colors lies a history of thousands of years, when this region was once a global trade hub. The people of Hormuz do something few places in the world can claim. They eat the earth. This red soil, rich in iron oxide and minerals known as galak, is mixed into bread, used as a seasoning, or even eaten on its own. It is not poverty, but a unique culinary tradition deeply connected to the island's unusual geology. Every morning, fishermen set out to sea on small wooden boats, following traditions passed down for centuries. And every morning, they share the water with steel giants over 300 meters long, carrying oil for the global economy. Two worlds could not be more different, yet they coexist on the same narrow stretch of water. Bandar Abbas, a city of 500,000 on the northern shore, exists because of Hormuz and lives through it. Its port is Iran's main trade gateway, where goods from around the world arrive and Iranian oil flows out. For the people here, geopolitics is not abstract. It is their jobs, their income, and their daily lives. As the sun sets behind anchored oil tankers, Hormuz reveals a breathtaking beauty, red, orange, and purple blending across the calm sea. It is a moment where grandeur and fragility coexist. The pure beauty of nature, and beneath it, the ever-present tension of geopolitics. Saudi Arabia and the UAE have built pipelines across the desert to reduce dependence on Hormuz. But their total capacity can only handle about 20% of the required oil flow. The remaining 80% has no route except the strait. And building more pipelines? It would cost hundreds of billions of dollars, take decades, and face nearly insurmountable terrain challenges. In theory, tankers could reroute around the Cape of Good Hope in Africa. But that would add thousands of nautical miles, weeks of travel, and dramatically higher costs. Oil prices would rise 10 to 15% from transport alone, and the world would need twice as many tankers. It is not impossible, just too expensive to be practical. The world is transitioning toward renewable energy, but far more slowly than headlines suggest. Oil will still dominate global energy at least until the mid-21st century. During this transition, Hormuz remains irreplaceable. Dependency does not disappear overnight, it fades gradually over decades. Experts have modeled a scenario where Hormuz is closed for just 48 hours. Within the first 6 hours, global financial markets begin to tremble. By hour 24, oil prices could exceed $200 per barrel. By 48 hours, some Asian governments may convene emergency cabinets. No war is needed, just 2 days of closure. Globalization has created unprecedented prosperity, but it has also created critical vulnerabilities. Hormuz is the clearest example. A $100 trillion global economy depends on a narrow 33-kilometer strip of water. That is not strength, it is fragility dressed as prosperity. Every oil tanker that passes safely through Hormuz is the result of a delicate balance between Iran and the United States, between Saudi Arabia and its neighbors, between geopolitical calculations and economic interests. Peace here is not luck. It is the product of constant restraint, day after day. And that restraint can break at any moment. Modern civilization is built on energy, and that energy must pass through Hormuz. We have created megacities, global supply chains, and complex transport networks, all relying on the uninterrupted flow through a strait narrower than a single city. It is one of the greatest contradictions of our time. Every morning, Hormuz awakens and continues its work, quiet, unseen, yet indispensable. As long as the world needs oil and economies remain interconnected, this strait will remain a crossroads of destinies. a narrow 33-kilometer strip of water, small on the map, yet carrying the weight of an entire civilization. From space, Earth holds a secret at its southern edge. A white, frozen, silent continent larger than Europe. A place where nature writes its own rules. Antarctica, the coldest, windiest, and most isolated continent on Earth. A land that belongs to no nation, no one. Only to time and to ice. Here, the sun does not rise or set in the usual sense. In summer, it circles the horizon endlessly, day and night. A golden light that never fades, surreal and desolate. More than 98% of Antarctica is covered by ice, averaging 2.3 kilometers thick. Beneath it lies a real continent, with mountains, valleys, and lakes, all buried for millions of years. In this absolute wilderness, life still finds a way. The emperor penguin, a symbol of endurance and will. It does not escape the cold. It chooses to live within it. In 1983, temperatures at Vostok Station dropped to minus 89.2 degrees Celsius, the lowest ever recorded on Earth. At such extremes, the air can freeze human lungs within seconds. Even breath turns to ice before it touches the ground. Katabatic winds, the most violent winds on Earth, can reach 320 kilometers per hour. They form as cold air rushes down from the ice plateau toward the coast. A single storm can bury an entire research station within hours. A whiteout, when sky and ground merge into a single field of white. Humans lose all sense of direction, unable to tell up from down. Many explorers have died just meters from their camps. Beneath the smooth snow lie crevasses hundreds of meters deep, hidden like invisible traps, waiting for the smallest mistake. One wrong step can be the last. In winter, Antarctica is plunged into darkness for 6 months. Temperatures drop further, winds intensify, and no rescue flights can reach it. Those who remain must face both the cold and complete isolation. Yet within the darkness comes something extraordinary. The aurora australis dances across an untouched sky. A cosmic display of light reserved for those brave enough to stay. Here, humans are not masters, they are only visitors. Every day is a test of body, mind, and will. Antarctica shows no mercy to carelessness, yet rewards those who respect it. The Southern Ocean encircles Antarctica like a vast natural moat. Here, the Pacific, Atlantic, and Indian Oceans converge. Waves rise up to 15 meters high, with no land to break the wind for thousands of kilometers. The Southern Ocean is the engine of global ocean circulation. Dense cold water sinks here, driving warm currents across the planet. If this system were to stop, Earth's climate would be transformed entirely. The Southern Ocean is the richest feeding ground for humpback whales. They migrate thousands of kilometers just to reach these waters each summer. Their songs travel for hundreds of kilometers underwater, a mysterious language of the sea. Krill, tiny creatures only a few centimeters long, form the backbone of the Antarctic ecosystem. A blue whale can consume up to 4 tons of krill each day. If krill disappear, the entire food chain collapses. Emperor penguins can dive deeper than 500 meters and hold their breath for over 22 minutes. Their bodies slow their heart rate to conserve oxygen. Beneath the surface, they become perfect hunters. Weddell seals are the southernmost living mammals on Earth. They carve breathing holes through ice to access the ocean in winter. Their calls echo beneath the ice like strange, otherworldly music. Icebergs are more than frozen water. They carry minerals and nutrients from land into the sea. As they melt, they feed algae, the foundation of the ocean's food web. The Southern Ocean generates the most powerful storms on Earth. With no land to block the winds, they circle the continent endlessly. Sailors named these waters the Roaring Forties, Furious Fifties, and Screaming Sixties. Calving, the moment when a massive block of ice breaks from a glacier and crashes into the sea. A single event can trigger waves like a small tsunami and thunderous echoes. This is how giant icebergs are born. The Lambert Glacier, the largest in the world, stretches over 400 kilometers wide and 700 kilometers long. It moves only meters per day, almost invisible to the eye. Yet its force can crush mountains and reshape the land itself. Each centimeter of ice core is a page in Earth's climate history. Tiny air bubbles inside hold ancient atmospheres. By studying them, scientists can read temperatures and air composition from 800,000 years ago. Ice core data reveals that today's CO2 levels exceed anything seen in 800,000 years. Ice does not lie, it only records truth. And that truth is warning us about what lies ahead. The Transantarctic Mountains stretch over 3,500 kilometers, one of the longest ranges on Earth. Yet most of it remains buried beneath ice, with only the highest peaks exposed. It forms a natural divide across the continent. Nunataks, peaks rising above the ice, are the loneliest rock islands on Earth. Only lichens and moss survive here. They stand as witnesses to millions of years of buried history. Using ice-penetrating radar and seismic waves, humans have mapped what lies beneath. Mountains higher than the Alps, valleys deeper than the Grand Canyon. A hidden continent sleeps beneath the ice. In 2000, iceberg B-15 broke from the Ross Ice Shelf, spanning 11,000 square kilometers, larger than Jamaica. It drifted for years before breaking apart. A single event like this can alter ocean currents and regional weather. Russia's Vostok Station sits at the heart of Antarctica, on an ice plateau 3,500 meters high. It is the coldest place ever recorded on Earth. And beneath it, buried under 4 kilometers of ice, lies one of science's greatest mysteries. Lake Vostok, stretching 250 kilometers long and 50 kilometers wide, is one of the largest lakes on Earth. Yet it has remained sealed beneath 4 kilometers of ice for over 15 million years. No light, no atmosphere, only water, pressure, and darkness. The water temperature is around -3 degrees Celsius, yet it does not freeze. Immense pressure from the ice above keeps it liquid. Geothermal heat from below sustains this extraordinary environment. In 2012, scientists drilled through the ice and reached the lake for the first time. In the samples, they found traces of microbial life living in total darkness. These organisms have been isolated since before humans existed. Lake Vostok has become a model for studying life beyond Earth. Europa, a moon of Jupiter, may hold a similar ocean beneath its ice. If life can exist here, it may exist there and far beyond. The greatest challenge is not drilling through 4 kilometers of ice. It is reaching the lake without contaminating it with surface microbes. If we fail, we may lose the truth forever. Lake Vostok still holds most of its secrets. We know it exists and that it may harbor life. But the true answers remain hidden in darkness, beneath 4 kilometers of ice. The Antarctic Peninsula is warming 3 times faster than the global average. Glaciers that have existed for thousands of years are retreating at unprecedented rates. Antarctica is changing, and that change will affect the entire planet. If all Antarctic ice were to melt, global sea levels would rise by 58 meters. Hundreds of coastal cities would disappear beneath the ocean. This is not science fiction, it is basic physics. Thwaites Glacier, known as the Doomsday Glacier, is losing mass at an alarming rate. If it collapses, global sea levels could rise by 60 centimeters. Its failure could trigger the collapse of even larger ice systems. Emperor penguins depend on stable sea ice to breed. When ice forms later and melts earlier, chicks cannot survive long enough to mature. In 2022, one colony recorded a 100% chick mortality rate due to ice loss. In 1959, the Antarctic Treaty declared the continent a place for peace and science. No nation may claim ownership. It remains the only fragile shield protecting Antarctica from division. More than 70 nations are present in Antarctica for science. Here, even rival nations collaborate and share data. It is one of the few places where science stands above politics. Every day, terabytes of data are sent from Antarctica to the world. Temperature, ice thickness, atmospheric data, marine life. Antarctica is Earth's early warning system, and it is sending signals. From above, drifting icebergs resemble fragments of another world. Each carries a story from the continent into the ocean. And those journeys are growing shorter as the ice melts faster than ever before. In Antarctica's summer, the sun never sets. It circles the horizon, casting an endless light. An experience that reshapes how we understand time and space. The submerged part of an iceberg is even more surreal than what lies above. Light filters through it, creating colors beyond description. A hidden world melting away before most will ever see it. Not all of Antarctica is silent. Adelie penguin colonies are loud and alive, like crowded cities. Life here is not fragile, it is fierce and resilient. Sometimes nature creates masterpieces without an artist. A perfect ice arch reflected in still water. No words are needed, only the understanding that this place must be protected. Aurora and ice share a single moment. One changes every second, the other has endured for millions of years. Yet both are now changing in ways we do not fully understand. Antarctica is not silent. It speaks through cracking ice, howling winds, and restless seas. It speaks through data and traces of life. The question is, are we listening? Antarctica reminds us that there are still places beyond human control, but not beyond human impact. We cannot own it, yet we can destroy it, and that is exactly why we must choose not to. The Atlantic Ocean, the second largest ocean on this planet, stretches across more than 106 million square kilometers. It is not only a vast body of water, but also the beating heart that regulates Earth's climate. Every living thing on land is touched in some way by its breath. Beneath the surface, colossal currents flow like invisible rivers. The Gulf Stream carries warmth from the tropics northward, heating the continent of Europe from thousands of kilometers away. It is one of the greatest climate engines Earth has ever created. From above, the Atlantic appears calm and endless. But beneath lies a living world that never truly sleeps. Millions of creatures are moving, hunting, and struggling to survive right now at this very moment. Every layer of water, every depth, forms its own ecosystem. From vast silver clouds of fish near the surface to strange creatures living without light in the abyss, the diversity here surpasses human imagination. The floor of the Atlantic hides mountains taller than the Alps and trenches deeper than Mount Everest. The mid-Atlantic ridge runs through the ocean like the spine of the planet. This majestic terrain shapes all life above it. The Atlantic is the birthplace of some of the most violent storms on Earth. Heat energy from warm water transforms into destructive power. Yet that same energy also sustains millions of creatures that depend on the ocean's motion. The humpback whale, a creature weighing up to 40 tons, can still launch itself clear above the sea in a breathtaking display. Each year, it migrates more than 8,000 kilometers, from warm tropical waters to the food-rich cold seas of the far north. It is one of the longest journeys made by any mammal on Earth. Humpback whales are brilliant strategists. Working together, they release giant rings of bubbles to trap schools of fish into a dense mass. Then the group surges upward from below, mouths wide open, swallowing tons of fish and water in a single strike. The song of the humpback whale is among the most complex sounds in nature. Males may sing continuously for up to 20 hours, their voices traveling thousands of kilometers through the sea. Each population has its own dialect, and the songs slowly evolve each year like a living culture. The warm waters of the Caribbean are where humpback whales give birth and raise their young. A newborn calf may already weigh 1 ton and drink hundreds of liters of milk each day. During the first months of motherhood, the female does not feed, devoting all her energy to her calf. The sperm whale is the undisputed deep-diving champion of the ocean. With its giant head housing one of the most advanced sonar systems on Earth, it can dive deeper than 3,000 meters. Their pressure is nearly 300 times greater than at the surface, yet it hunts with ease. Kilometers below the surface, in total darkness, sperm whales confront giant squid. These legendary battles may last for hours, yet no human has ever witnessed one directly. The only evidence is the massive sucker scars left on the whales when they return to the surface. The great white shark is an icon of ocean power. It can migrate more than 20,000 kilometers each year, crossing the full width of the Atlantic and returning to the exact point where it began. By sensing Earth's magnetic field, it navigates with the precision of a living compass. On the snout of the great white shark are thousands of electroreceptors called ampullae of Lorenzini. They can detect electric fields billions of times weaker than what humans could sense. Even when prey is buried beneath the sand, the shark can pinpoint its location by sensing the victim's heartbeat. Bluefin tuna are the marathon racers of the sea. They can swim at speeds of 70 kilometers per hour and sustain powerful movement for thousands of kilometers. Each year, they cross the Atlantic to spawn in the Mediterranean, then return to the rich feeding grounds of the Western Ocean. Bluefin tuna possess a rare ability among fish. They can keep their body temperature up to 20 degrees Celsius warmer than the surrounding water. Their heat exchange system works like an internal furnace. This allows their muscles to perform at maximum power in waters of any temperature. Leatherback sea turtles are tireless long-distance travelers. They migrate from the shores of the Americas to Africa in search of food, completing round trips of more than 16,000 kilometers each year. After decades away, females still return to the very beach where they were born to lay eggs. Manta rays look like giant flying carpets gliding through the sea. Though their wingspan can reach 7 meters and they weigh several tons, they feed only on tiny plankton. They are among the most intelligent ocean creatures and can recognize themselves in a mirror, a rare trait in the animal kingdom. Atlantic salmon undertake one of nature's most tragic and heroic journeys. They spend years at sea, then return to the exact river where they were born to spawn and die. They leap waterfalls, battle raging currents, and stop eating entirely, all to fulfill the final purpose of their lives. The Sargasso Sea, in the heart of the Atlantic, is the only sea on Earth with no shores, bounded entirely by ocean currents. European and American eels both swim here from opposite sides of the ocean to spawn and die. Their young then begin the long journey back to continents their parents never knew. Atlantic creatures do not move at random. They read the ocean the way humans read maps. Water temperature, current direction, salinity, and light are invisible but precise signals that species have learned to decode through millions of years of evolution. The call of a blue whale can reach 188 decibels, louder than a jet engine. This sound travels thousands of kilometers through the ocean by means of a special water layer known as the SOFAR channel. Two whales on opposite sides of the Atlantic may still hear and communicate with one another. Dolphins do far more than swim. They are playful, curious, and remarkably intelligent. Their sonar is so precise that it can detect an object the size of a coin from 100 meters away in total darkness. Each dolphin has its own signature name that other members of the pod instantly recognize. Octopuses are the masters of camouflage. In less than a second, they can change color, patterns, and even skin texture to blend perfectly into their surroundings. Strangely, Octopuses are colorblind, yet they still camouflage flawlessly. Science has not fully solved this mystery. The bait ball is one of the most dramatic spectacles in the ocean. Millions of small fish pack tightly into a spinning sphere for protection. From above, birds dive down. From below, large fish and dolphins attack. From the sides, sharks slice through. It is a perfect siege from every direction. Horseshoe crabs have existed for 450 million years, older than the dinosaurs. Every year, during the full moon nights of May, millions crawl onto Atlantic beaches to breed. It is one of the largest and most ancient mass migrations still surviving on this planet. Swordfish can warm their brains and eyes to see more clearly in cold, deep water, an extraordinary adaptation that helps them hunt efficiently across many depths. They can reach speeds of 100 kilometers per hour in short bursts, making them one of the fastest marine animals on Earth. Each night, the sea becomes an upside-down sky of stars. Trillions of bioluminescent plankton illuminate the ocean from within. This phenomenon is not only beautiful, their living light is also a language for communication, warning predators, and attracting mates in the darkness below. Atlantic coral reefs are miniature cities beneath the sea. Though they cover only 0.1% of the ocean floor, they shelter more than 25% of all marine fish species. Every reef is a complex living network where each species plays an irreplaceable role in the ecosystem. The largest creature is not always the most powerful. The lionfish is small, yet armed with deadly venomous spines and bright fins like warning flags to the sea. It does not need to flee or hide. It stands proudly still and lets the entire ocean know, never come too close. Below 200 meters, sunlight disappears completely. Temperatures fall close to freezing. Pressure becomes strong enough to crush a truck. This is the gateway to another world, the dark, deep sea that makes up nearly 95% of the volume of Earth's oceans. Deep-sea anglerfish carry a living lantern above their heads, a glowing organ powered by symbiotic bacteria. In total darkness, this tiny light becomes the perfect trap. Curious prey swims toward the glow and straight into a mouth of long, waiting teeth. Atlantic giant squid can grow up to 13 meters long, larger than a city bus. Their eyes, as wide as dinner plates, are the largest in the animal kingdom. In the deep darkness, those remarkable eyes can detect the faintest light from distant predators. In the dark, deep sea, food falls from the sky, an underwater sky. Marine snow is made of endless organic fragments, dead creatures, waste, and shed scales drifting down from above. It is the main source of energy for the deep ecosystem, a constant rain of nutrients that never stops. Deep-sea dragonfish look like monsters from science fiction, yet their bodies are only a few dozen centimeters long. Their transparent fangs are so large the mouth cannot fully close. Rows of glowing lights along the body flash to communicate or lure prey, like a living spacecraft shining through the dark. Dumbo octopus lives at depths of up to 7,000 meters, making it the deepest living octopus known to science. It swims by gently flapping ear-like fins, gliding through the darkness like a ghost. Under immense pressure, its body does not collapse because it contains no hollow air spaces. Newly hatched sea turtles begin their journey alone into the ocean, with no guide and no map. They navigate using Earth's magnetic field and warm currents, living among drifting seaweed mats like floating lifeboats. These are the most mysterious years of a turtle's life, known to science as the lost years. Despite its name, the vampire squid is neither a true squid nor an octopus, but a separate evolutionary lineage that has existed for 300 million years. When threatened, it turns itself inside out, covering its body with sharp spines like armor, a defense strategy unlike anything else in nature. Deep-sea glass shrimp solve camouflage in the most extreme way possible, by becoming completely transparent. Their bodies are like glass, allowing light to pass through without reflection, so predators see only the ocean beyond. Their red organs are the only visible part, but at depth red light disappears, making them effectively invisible. Humanity reached the moon before fully exploring the seafloor of its own planet. Even today, only a little over 20% of the ocean floor has been mapped in detail. Every deep dive reveals new discoveries, creatures never before named, living in a world utterly foreign to us. On the floor of the Atlantic, where not a single photon of sunlight can reach, vibrant oases of life still exist. Hydrothermal vents blast water as hot as 400 degrees from deep within Earth. These are ecosystems that do not depend on the sun. They run on energy from the planet's interior. Giant tube worms, reaching up to 2 meters long, survive entirely through chemosynthetic bacteria living inside their bodies. They have no mouth, no stomach, and no digestive system. Instead, the bacteria convert vent chemicals into food and sustain their host, a perfect alliance between two forms of life. The Yeti crab looks like a creature from legend, with claws covered in white fur. In reality, those are long filaments that host chemosynthetic bacteria. The crab waves its arms and vent water to grow the bacteria, then feeds on them, a perfect self-sustaining farm carried on its own hands. Hydrothermal vents reveal something once thought impossible. Life does not necessarily need sunlight. Their discovery in 1977 transformed humanity's understanding of the limits of life. Today, scientists are searching for similar vents beneath the ice of Europa, a moon of Jupiter. The ocean is absorbing more than 90% of the excess heat caused by climate change. Warmer waters push food sources toward the poles, forcing entire migration chains to adapt. Species that fail to adjust will arrive at old feeding grounds and find nothing waiting for them. A rise of just 1 degree Celsius can cause corals to expel their symbiotic algae and turn ghostly white, a phenomenon known as coral bleaching. Without algae, corals cannot photosynthesize and slowly die. In recent decades, more than half of Atlantic coral reefs have disappeared. When coral dies, an entire city of marine life collapses with it. Every year, hundreds of thousands of large marine animals die after becoming trapped in abandoned fishing nets. Known as ghost nets, lost or discarded traps drifting endlessly through the sea. They continue killing for decades. Whales, sea turtles, and sharks are all vulnerable to these invisible snares. More than 8 million tons of plastic enter the ocean each year. Sunlight breaks it down into microscopic particles called microplastics, smaller than grains of sand. These particles enter the food chain from plankton to fish to whales and eventually onto our own plates. The ocean is returning what we threw into it. Yet across the Atlantic, people are fighting to protect it. Scientists attach satellite tags to whales to understand their migrations. That data is shaping conservation policy, creating no-fishing zones, and forcing ships to change course to avoid whale collisions. The Atlantic has existed for hundreds of millions of years and has witnessed the greatest mass extinctions in the history of life. It recovered each time. But the speed of change today is unlike anything in geological history. The future of this ocean, and every extraordinary creature within it, depends on the choices our generation makes right now. The ocean has always guarded secrets beyond explanation. For thousands of years, sailors told stories that no one believed, gigantic walls of water appearing from nowhere in the darkness of night. Viking sailors, Mediterranean traders, and Japanese fishermen all described waves higher than 30 meters. But no one recorded them with hard measurements. And because of that, no one believed them. Throughout the 19th and early 20th centuries, physics described ocean waves with simple linear equations. Under that theory, a 30-meter wave was nearly impossible. Science chose mathematics over the testimony of sailors. Survivors of giant waves were often dismissed as confused or exaggerating. Their testimony was rejected even when ships were completely destroyed. The sea never needed to prove what it had done. In the 20th century alone, hundreds of large ships vanished without a trace along major sea routes. No distress signal, no significant wreckage. Reports simply stated, "Cause unknown." To understand why this is terrifying, imagine this. Ordinary storm waves are around 4 to 6 meters high. A rogue wave can be 5 times taller, equal to a 10-story building, and it appears within seconds. Even in the largest storms, modern ships can handle waves up to a certain limit. But rogue waves do not always come with storms. They can appear in moderate seas, without warning and without clear reason. For centuries, maps of mysterious ship disappearances formed a strange pattern, clustering in certain regions of the world. But science had no answer, until one day in late 1995. January 1st, 1995, the Dropner oil platform stood in the North Sea. Automatic sensors recorded wave data continuously, just like any normal day. No one knew that night would change scientific history. At 3 p.m., the sensors recorded something extraordinary. While surrounding waves were only 11 to 12 meters high, one solitary wave reached 25.6 meters. More than twice as large, exactly as sailors had long described. When the data was analyzed, the scientific community was stunned. For the first time in history, a rogue wave had been captured by scientific instruments. Impossible to doubt, impossible to deny. The Dropner wave, as it became known, marked a historic turning point. Within a few years, dozens of studies were published. The door to an entirely new scientific field had opened. To put it in perspective, the largest container ships in the world may rise about 70 meters from the waterline. But the section directly exposed to waves, the hull above sea level, is only around 15 to 20 meters high. A Dropner-sized wave could engulf many modern ships. In 2003, the European Space Agency used radar satellites to scan the oceans. In just 3 weeks, they detected 10 rogue waves around the world. They were not as rare as anyone believed. Under older probability models, a wave like Dropner should appear only once every 10,000 years. But satellite data showed they were happening somewhere on the ocean almost every week. The old theory was completely wrong. Researchers began reopening old records. Many shipwrecks once blamed on unusually bad weather now had a more convincing explanation. Rogue waves had been killing people for centuries before science admitted they existed. What makes rogue waves especially dangerous is not only their height. Their front face can become nearly vertical, more like a wall of water than a normal wave. There is nothing for a ship to climb or ride over. Measurements show that rogue waves can exert around 100 tons of pressure per square meter. By comparison, ordinary structural steel may withstand only 25 to 30 tons per square meter. A rogue wave can bend and tear open a steel hull like paper. On the cruise liner Queen Elizabeth II, a giant wave bent thick steel plates and shattered bridge windows 22 meters above the waterline. The captain later described it as climbing a cliff. The danger does not come only from the crest. Ahead of many rogue waves is a deep trough, often called the Hole of Death. A ship is dragged bow first downward, just as the wall of water crashes down from above. In 1978, the cargo ship MS München, one of the most advanced and safest ships of its time, vanished completely in the Atlantic Ocean. 28 sailors were lost. The only recovered lifeboat had twisted mounting hooks, evidence of an impact force estimated in the tens of tons. At least 22 supercarriers were lost between 1969 and 1994, before science proved rogue waves existed. Today, many researchers believe a large share of those sinkings were linked to this phenomenon. The true number may be far higher. An important distinction: rogue waves are not tsunamis. Tsunamis are generated by earthquakes and travel thousands of kilometers. Rogue waves form locally and suddenly, with no conventional warning system able to detect them early enough. How can a gigantic wave appear from nowhere? Science proposes several different mechanisms. The first and most intuitive is wave reinforcement, when many waves from different directions meet at the right place at the right time. When the crests of two waves align, they reinforce each other and create a taller wave. Across the vast ocean, dozens of waves from different storms can converge at one point. The result is a single wave carrying the combined energy of them all. The second theory involves ocean currents. The Agulhas Current near southern Africa flows against large swells arriving from the Indian Ocean. When waves meet an opposing current, their energy is compressed and wave height can rise suddenly. This mechanism helps explain why waters off South Africa are among the most dangerous on Earth for shipping. Large swells from the southern Atlantic meet the Agulhas Current, and sometimes an abnormal wave is born. The third theory, and the most complex, is nonlinear interaction. Under certain conditions, waves do not simply add like normal arithmetic. Energy leaks from smaller waves into larger ones, creating an avalanche effect. In laboratories, scientists have successfully recreated this phenomenon in scaled wave tanks. When tuned to the right frequencies, small waves suddenly collapse into one giant solitary wave, just like what happens in the real ocean. More frightening still, rogue waves are not caused by only one mechanism. All three processes can happen simultaneously at the same point. When they do, a wave can rise almost instantly with more energy than any ship was designed to withstand. Modern computer simulations show that rogue waves do not last long. They form within seconds, reach a peak, then collapse again in under a minute. But that is enough time to destroy anything in their path. Statistical analysis shows that real ocean wave height distributions have fat tails, meaning extreme events happen far more often than standard Gaussian models predict. This is why the old theory failed completely. Although rogue waves can appear in any ocean, some regions are recorded far more often than others. These are places where strong currents, heavy winds, and seafloor topography combine to create ideal conditions for the phenomenon. Waters off the east coast of South Africa are among the most dangerous on Earth. The Agulhas Current races southward against giant swells arriving from the 40 to 50 degrees southern latitudes, a zone sailors call the Roaring Forties. The Gulf Stream in the North Atlantic is another hotspot. When giant winter waves from the north meet the warm opposing current, the probability of rogue waves rises sharply. It is also the busiest shipping route linking Europe and North America. The North Atlantic in winter is one of the harshest seas in the world. Successive low-pressure systems make 8 to 12-meter waves normal conditions. In that environment, a rogue wave can hide among seas that are already enormous. Seafloor topography also influences rogue wave formation. Where ocean depth changes suddenly, wave energy can be focused much like light through a lens. Regions with deep trenches beside continental shelves are especially dangerous. The North Sea, where the Dropner platform recorded historic evidence, is also on the danger list. It contains hundreds of oil platforms, and many mysterious structural damage incidents are now being reconsidered in a new light. A new concern is emerging. Climate change is altering global wind patterns and ocean currents. Some researchers warn this could increase rogue wave frequency in regions once considered less dangerous. The most important question today is no longer whether rogue waves exist. That has already been proven. The question is, can we predict them in advance? And if so, how much warning time is needed to save lives? Today, NOAA and equivalent agencies in Europe operate thousands of wave monitoring buoys across the oceans. Data from these buoys is transmitted continuously, providing a real-time global picture of sea conditions. Artificial intelligence is being brought into this battle. Machine learning models are trained on millions of historical wave data points, searching for precursor patterns that may appear before a rogue wave forms. But this remains an extremely difficult challenge. Early results suggest warning signals may be detected 2 to 4 minutes before a rogue wave fully forms. With modern communication systems, that could be enough time for a crew to carry out basic protective measures. Modern radar satellites can scan vast ocean areas in only minutes. Combined with surface buoys and AI models, a global early warning system is slowly taking shape, though it may still take years to fully mature. Alongside forecasting, shipbuilding is evolving as well. Some new ship designs include reinforced bows and strengthened vulnerable sections, applying what we have learned about the true force of rogue waves. Today's young scientists grew up in a world that already accepts rogue waves as reality. They no longer need to convince others the phenomenon exists. They can focus directly on one question: how do we protect people from it? The chance of one specific ship encountering a rogue wave on a single voyage is very low. The ocean is vast, and although these waves are more common than once believed, they remain extreme outliers on a broad spectrum. But when small probability meets massive scale, the consequences can be catastrophic. The story of rogue waves is a lesson in intellectual humility. For centuries, we denied what those who lived at sea understood through direct experience. Sometimes the best evidence is not an equation, but survival itself. The ocean covers more than 70% of Earth and still holds countless mysteries. Rogue waves remind us that nature is always more complex than our models. Each time we think we fully understand it, the ocean finds a way to prove otherwise. Rogue waves appear suddenly, violently, then vanish as if they never existed. They are among the most terrifying and mysterious phenomena nature has created. And somewhere out there, right now, in the darkness of the deep ocean, a wave like that may already be forming. The ocean covers more than 70% of the Earth. Here, there are no rules, only the strong and the weak, predator and prey. Every species has found its own way to survive. Beneath the surface lies a completely different world. Here, life and death are separated by just a second. Speed, intelligence, and coordination determine everything. Today, we will witness 6 species and 6 different survival strategies. None are perfect, yet each has endured through millions of years of evolution. Flying fish are among the strangest creatures in the ocean. They possess wide pectoral fins and an incredibly powerful tail, 2 survival tools refined over millions of years of evolution. When danger strikes, flying fish do not hide. They escape their predator's dimension. With powerful tail beats reaching speeds of 70 kilometers per hour, they launch into the air. In the air, they can glide over 200 meters using wind and momentum alone. In this moment, they are truly free, beyond the reach of predators below. But freedom comes at a cost. Above, seabirds patrol the skies. The flying fish escapes one danger below, only to enter another above. And the moment they touch the water, the Dorado is already waiting. A clever predator that has learned the pattern. Flying fish must land. The only question is where and when. The strategy of flying fish is simple yet bold, using speed and 3-dimensional space to escape. They cannot hide, they cannot fight, they can only fly. And sometimes, flying far is enough to survive. Sardines have no great speed, no sharp weapons, no armor. The only thing they have is each other. And they have turned that weakness into a strategy. The bait ball is one of the most complex defensive structures in the ocean. Each fish swims tightly beside the next, reflecting light and creating the illusion of a massive, chaotic organism. To predators, the shoal creates visual confusion. Millions of flashing reflections overwhelm the brain, making it nearly impossible to target a single fish. Inside the sphere, there is a harsh order. The weaker fish push toward the center, the safest place, while the stronger ones are forced outward, becoming a living shield for the group. But when multiple predators attack at once, the strategy collapses. The shoal is compressed from all sides, space shrinks, and the defensive sphere becomes a deadly trap. Strength in numbers only works while the group holds together. Once it breaks, what was once a shield becomes a perfectly packaged feast for predators. Dolphins do not hunt with strength, they hunt with intelligence. They are among the few ocean predators with strategies rivaling those of primates on land. They assign roles with precision. One group forms the outer line to block escape, while another drives the shoal toward the shore. No commands are spoken. They communicate through sound and body signals. Wave-making is the peak of this strategy. Moving in perfect sync, dolphins generate currents that force prey into shallow water, where there is no room to escape. Strand feeding, hunting by surging onto land, is one of the rarest and most dangerous techniques. The entire group rushes ashore on one side, cutting off every escape route. The risk is extreme. A delay of just seconds can leave a dolphin stranded. Over time, sand wears down their teeth, the long-term cost of a strategy that demands perfect precision. But when it works, the efficiency is nearly perfect. This is not luck. It is the result of thousands of hours of learning, observation, and knowledge passed down through generations. When the feeding frenzy begins, tuna strike from below, birds dive from above, and sharks circle all around. That is when the latecomer arrives. And this hunter needs no complex strategy. A bride's whale can weigh up to 20 tons and reach 15 meters in length. It does not need speed or coordination. Size and gravity are the only weapons it needs. With its mouth wide open, the massive body surges straight through the shoal. In seconds, tons of fish disappear. No refined technique, just raw power applied at the perfect moment. Baleen plates trap the fish while expelling water. A single lunge can yield hundreds of kilograms of food, equal to days of hunting for other predators. After the strike, the remaining fish are still hunted by others. The whale takes the largest share, then disappears. The bride's whale is the finisher, arriving after the prey has been cornered, taking the biggest reward with the least effort. This is the strategy of ultimate power. This is one of the most extraordinary spectacles in nature. Completely different species hunting together without language, without agreement. Tuna strike from below. They are the speed machines of the ocean, reaching up to 70 kilometers per hour perfectly built to tear through prey formations. Copper sharks circle from all sides, preventing the shoal from expanding. They do not rush, they wait, observe, and strike at the perfect moment with minimal effort. Seabirds attack from above. Their dive speed and force allow them to precisely target fish exposed at the surface. The most remarkable part is this: they do not attack one another. There is no communication, yet each species seems to understand its role and boundaries. Pressure from above, below, and all around leaves the shoal with no escape. This is a perfectly evolved hunting system shaped over millions of years. They take turns attacking, no chaos, no conflict. This level of efficiency is not learned. It is deeply embedded in instinct through evolution. When the tide retreats, a new world emerges. Isolated pools, stranded crabs, and trapped fish become a paradise for a creature that can walk. The octopus is a master of camouflage. Its skin can change color and texture in less than a second, turning it into whatever surrounds it. On land, its 8 arms become 8 legs, each lined with hundreds of suckers, not just for grip, but for sensing temperature, taste, and texture. Air is its weakness. Its skin must stay moist to breathe, so it moves quickly, never lingering on dry ground, always choosing the shortest path between pools. In the new pool, its arms spread like a sensory network. The crab has no chance. The octopus strikes from the one angle it cannot defend. The octopus does not need the vast ocean. It extends its hunting grounds onto land, where almost no rivals exist. Adaptability is its ultimate weapon. While others are limited by their environment, the octopus simply overcomes those limits, a very different and highly effective evolutionary strategy. Flying fish choose a third path, neither fully in water nor entirely in air. They live in the space between two worlds, and that space is their survival. Sardines show that weakness can become strength when organized. Alone, they cannot survive, but together, millions form an almost impenetrable entity. Dolphins prove that intelligence is not exclusive to humans. Planning, role assignment, and learning from experience all exist beneath the ocean's surface. The bride's wail reminds us that sometimes the best strategy is patience and timing. You do not need to be first. Sometimes the last to arrive holds the greatest advantage. The multi-species hunting system is the purest example of cooperation without language. No one leads, no one commands, yet it operates with near-perfect precision. The octopus is the ultimate example of adaptability. In a world where most species specialize in one environment, it chooses to master them all. From a distance, the ocean appears calm. But beneath the surface, every second is a battle, a strategy, a lesson in survival shaped over millions of years. Three core strategies: intelligent escape, collective defense, and coordinated attack. Each species follows a different path, and each path leads to survival in its own way. The ocean has no audience, only creatures fighting every day to survive. And in this struggle, there is no perfect strategy, only one that is good enough to live another day. The stretch of ocean between Florida, Puerto Rico, and Bermuda became known as the Devil's Triangle, a name that sent chills down people's spines. Dozens of ships and aircraft vanished here without a trace. And the most famous story began on December 5, 1945. It was an ordinary afternoon at the naval base in Fort Lauderdale. 5 Avenger torpedo bombers were carefully inspected and ready for takeoff. The mission was only a routine training exercise expected to last about 2.5 hours. Leading the squadron was Lieutenant Charles Taylor, an experienced pilot with hundreds of flight hours. With him were 13 younger pilots and navigators. None of them knew this would be their final flight. At 2:10 p.m., Flight 19 took off and headed east over the Atlantic Ocean. For nearly 2 hours, everything went normally. There was no sign of what was about to happen next. At 3:45 p.m., the control tower received a transmission from Taylor. The compasses were malfunctioning. He could no longer determine where west was. The ocean below looked strange in a way he could not explain. Taylor reported, "We don't know where we are. The ocean doesn't look as it normally should." There was no land, no islands, no point of reference. Only the endless ocean stretching in every direction. The other pilots began arguing over which direction to fly. Some believed they should head west, others thought south. Taylor insisted on staying the course, convinced they were flying over the Gulf of Mexico. As fuel levels dropped toward empty, Taylor ordered the squadron north in search of land. But every change in direction only carried them farther from shore. Darkness was closing in. At 5 p.m., the radio signal grew weak and broken. Taylor's final recorded words were, "Keep all planes close together. When the first plane runs out of fuel, we all go down together." Then silence. Five Avenger aircraft and 14 men vanished into the night over the Atlantic Ocean. No wreckage, no bodies, and no distress signal were ever found. Flight 19 became legend. As soon as Flight 19 lost contact, the U.S. Navy dispatched 2 PBM Mariner rescue aircraft. These long-range patrol planes were specially designed for search missions over the sea. But the unimaginable was about to happen. Just 23 minutes after takeoff, one of the 2 rescue aircraft completely lost contact with the control tower. The tanker SS Gaines Mills reported seeing a large fireball in the dark sky. Yet no trace was ever found afterward. A total of 27 men disappeared in a single day, an unprecedented tragedy in American civilian and military aviation history. The search continued for days but produced no results. The U.S. Navy Investigation Board concluded, "Cause unknown." It was a diplomatic phrase for something they truly did not understand. That conclusion only fueled the mystery surrounding the Bermuda Triangle. No family received the body of a loved one for burial. No satisfying answers were ever given. Pain and mystery remained intertwined for decades afterward. Flight 19 became a wound that never healed. Three years after Flight 19, in January 1948, the Tudor IV airliner Star Tiger departed from the Azores bound for Bermuda. It was a routine commercial passenger flight across the Atlantic islands. With less than 2 hours remaining before reaching Bermuda, Star Tiger suddenly went silent. There was no distress signal and no message from the crew. A 5-day search found no wreckage at all. The British Investigation Board declared, "What happened to Star Tiger remains an unsolved mystery." That same year, another aircraft would vanish in nearby waters under similarly mysterious circumstances. In December 1948, a Douglas DC-3 with registration NC 16002 departed from San Juan bound for Miami. On board were 31 people, 27 passengers, and 4 crew members. They never arrived. The pilot sent a final message when only 50 miles from Miami, reporting that everything was normal and the city lights were visible. Then silence. Not a single piece of wreckage was ever found despite a massive search effort. One of the most common theories involves magnetic anomalies in the Bermuda Triangle. The seafloor here contains mineral deposits with strong magnetic properties, especially magnetite. These could cause magnetic compasses to drift by several degrees. In 1945, aircraft and ships depended entirely on magnetic compasses for navigation. There was no GPS and no satellite positioning system. If the compass was wrong, pilots had no reliable way to confirm their true location. Charles Taylor himself reported that the compasses were malfunctioning. He believed he was flying over the Gulf of Mexico when he was actually over the Atlantic Ocean. A small navigational error, multiplied over hours of flight, became fatal. Modern studies confirm that localized magnetic anomalies exist in parts of this region. But they are not strong enough to seriously affect modern equipment. With the crude instruments of the 1940s, however, the consequences could have been far more severe. Many scientists consider this the most plausible explanation for Flight 19. Not the supernatural, not aliens, just basic physics and outdated technology placed in an unforgiving situation. The seafloor beneath the Bermuda Triangle may contain giant methane pockets formed from the decay of ancient organisms. When pressure builds high enough, they can erupt suddenly and violently toward the surface. When a large volume of methane suddenly rises, the density of the water drops instantly. Large ships could lose buoyancy at once and sink straight down before sending a distress call. This could explain why no floating wreckage is sometimes found. For low-flying aircraft, methane entering the engine system could cause engine failure. Flames from the engines meeting a methane cloud could trigger an immediate explosion. This theory attempts to explain the disappearance of both ships and aircraft. Geologists have confirmed the presence of methane hydrates in this region. Some studies, including research published in 2003 by Australian scientists, suggest that major gas eruptions in the past may have been powerful enough to sink medium-sized ships within minutes. However, no accident has ever been directly observed and conclusively linked to a methane eruption. The theory remains under investigation and has not been fully proven. The Bermuda Triangle lies within one of the most active tropical storm regions on Earth. Storms over the Atlantic Ocean can form and intensify rapidly here, sometimes within only a few hours. Massive waves combined with violent winds can sink small and medium ships within minutes. For aircraft, turbulent air from storms can cause total loss of control. In 1945, there was no weather radar, so pilots had no way of knowing where storms were. On the day Flight 19 vanished, weather reports indicated rapidly changing conditions by late afternoon. There were no early warning systems and no real-time data. Pilots could fly directly into a storm without realizing it. One lesser-known factor is the rogue wave, giant walls of water that appear suddenly without warning. Reaching heights of up to 30 meters, they can rise in calm seas and destroy everything in seconds. Data from NOAA confirms that the Bermuda Triangle is one of the most meteorologically unstable regions on Earth. This factor alone may explain the majority of reported disappearances. Before the GPS era, navigating over the ocean required great skill and was highly prone to error. Pilots had to determine position through celestial navigation, measuring stars, calculating by hand, and relying on clear skies. Charles Taylor was an experienced pilot, but he had limited flying time east of Florida. Investigators believe he misidentified the islands below him. Instead of recognizing the Bahamas, he believed he was seeing the Florida Keys. When Taylor turned north based on that mistaken belief, the squadron moved farther into the Atlantic Ocean. Fuel ran out before anyone could correct the error. It was a tragedy created by human misjudgment, not supernatural forces. Taylor's family rejected that conclusion. They believed he was an exceptional pilot who could not have made such a basic mistake. But even the most skilled professionals can fail under stress and limited information. This was the harsh reality of pre-GPS aviation. Lack of information leads to wrong judgment leads to wrong decisions, and wrong decisions over a dark ocean leave no chance for recovery. The Bermuda Triangle became a pop culture phenomenon in the 1970s when Charles Berlitz published The Bermuda Triangle, which sold more than 20 million copies worldwide. He combined many disappearances from different locations into one supernatural narrative. What few people know is that Lloyd's of London, the world's most famous maritime insurer, does not charge higher premiums for vessels crossing the Bermuda region. If it were truly abnormally dangerous, they would have known first. In 1975, researcher Lawrence David Cush examined each disappearance cited by Berlitz. He found that many occurred outside the triangle, some were exaggerated, and some were entirely fabricated. When disappearance rates are adjusted for the density of ship and aircraft traffic, the Bermuda Triangle is not exceptional. The Mediterranean Sea, the South China Sea, and waters around Japan actually show higher accident rates. In 2010, NOAA stated that there is no scientific evidence showing accident rates in Bermuda are higher than normal. The legend had grown larger than reality. Most experts today agree on a combined explanation. Severe weather, navigational mistakes, outdated technology, and harsh ocean conditions are the true causes. No supernatural force is required. Every year, thousands of flights and tens of thousands of ships pass safely through the Bermuda Triangle. With GPS, radar, and satellite communication, this region is no more dangerous than anywhere else. The seafloor of the Bermuda Triangle has been surveyed in detail using modern sonar technology. No strange structures or signs of mysterious forces have been found. Only the normal geology of a tropical ocean basin. The real mystery is not the disappearances, but why people so deeply want to believe in mysteries. We search for extraordinary stories in a world where ordinary explanations often feel less satisfying than legend. The Bermuda Triangle will remain a symbol of mystery in human culture, not because it is more dangerous than other seas, but because it reminds us that the ocean is vast, majestic, and still not fully understood.